This is the MCAT 2017 Day 2, Question 3. Give the equation for m in terms of n. So what we're going to have is m equals and then everything else. Now looking at this, I've got n over on that side, so I'm going to start manipulating things. Now because I've got a little sort of minus 16 that doesn't have any letters, I'm going to take that over to the other side first. I want to have n plus 16 equals 9m squared. So I've just taken that, I've added 16, not 61, 16 to both sides. And then I've got this equation. So now what I want to do is divide both sides by 9, the whole thing, so that that cancels out. So I've got n plus 16 divided by 9 equals m squared. Now, how do I get rid of a squared? I need to square root. So the square root cancels with the squared, and I need to square root that whole thing. So that's going to give me n plus 16 over 9 equals m, and this whole thing is square rooted. Now you can actually take this 9 out. It'll give you 1/3. So if you wanted to, you could do that, and you'd have 1/3 in front of it equals m. But that isn't really going to make much of a difference. Next one. Simplify. Now, I've got pluses and minuses and pluses and minuses at the bottom there. So what I would like to do is change my addition sums into multiplication sums. And the thing that does that for me is factorizing. Factorizing changes plusing and minusing into timesing. So first of all, let's look at the top. Is there any common factors in there? Well, yes, I think 6 is a factor of 6 and 18, and so is x. I'm going to open my bracket. I need to multiply it by x, and 6 times 3 is 18, and that'll give me the x there as well. And when I look at this over here, I see that there is a coefficient of the x squared, so a number in front of the x squared. That's not just 1. So I need to multiply those two together. So 2 times 3 gives me 6. So my factor pairs of 6 are 1 and 6, and 2 and 3. And it looks like 1 and 6 is going to give me the 7 that I require. So I am just going to, and they both need to be minus. So I will have 2x squared minus 1x minus 6x plus 3. I'm just going to write that down there. So 6x, x minus 3, and I've got to carry on factorizing this. This side, I can see that there is a common x, and I've got 2x minus 1, and here if I take out a minus 3, actually I'm going to take out a plus 3. No, I am actually going to take out a minus 3. Why am I taking out a minus 3? So that this is going to have to change to a minus as well. I'm looking for a minus 1 there. So take out a 3. This will give me 2x. Negative 3 times positive 2 gives me negative 6x. And if I want a positive 3, I actually have to times it by negative 1, because a positive times a negative gives me a positive. Sorry, a negative times a negative gives me a positive. So that's all under one thingy. So now I have common brackets. I've still got this 6x, x minus 3 up the top there. I am taking up all the space that I've been given. Okay, so I've factorized that, and then now I can simplify those. So I'm left with 6x over 2x minus 1. And there is nothing I can do with that. So that is it in its simplest form. Next one. 5 to the power of x squared minus 6 is greater than 5 to the power of x. So if I've got something, 5 to the power of something and 5 to the power of something, if this side is larger than this side, then this x squared minus 6 must be larger than the x because it's making this power larger. So this 5 larger. So x squared minus 6 must be larger than x. And I'm going to minus this x from that side. So be x squared minus x minus 6 is greater than 0. So now I have a quadratic. Now it's greater than 0. I know that a quadratic gives me a parabola. And if I've got a parabola, sometimes some of it is greater than x. So that bit there is all greater than x. And that bit there is, that's less than, that's greater than. Okay, so let us just see if I can factorize this. So what are my factors of 6? Factor pairs of 6 that can add or subtract to give me negative 1. So be minus 3 and plus 2. Those are too big. So it's going to be in my bracket x plus 2, x minus 3 is greater than 0. Now, this is telling me, and hopefully you remember from your tables, equations, and graphs, that I've got an x at negative 2 there, and I've got an x root at positive 3 over there, and there's my y-axis. Diagram not to scale. Special conditions apply. See in store for details. So I've got a parabola. I'm looking for where is this parabola larger than 0? Where is it greater than 0? Well, this is where it's greater than 0, up the top here. So it's greater than 0 where x is less than negative 2, or where x is greater than 3. Now there's no context here. I don't have to ignore any negatives. I am just, well, actually, let's have a look. There's a little bit of context because we've got this over here. So if I had to say x was negative 2, remember if you've got anything to the power of a negative 2, it makes it smaller. It makes it into a fraction. So say if x had to be less than negative 2, if x was negative 3, for instance, then I would have 5 negative 3 squared minus 6 is greater than, that's a greater than, not a 7. Then 5 to the negative 3. So there I've got negative 3 squared is 9. 9 minus 6 is 3. So it's saying 5 to the power of 3 is larger than 1 over 5 to the power of 3, which is true. So that's fine. And if it was greater than 3, so say 4, let's just check. I would have 5. Where'd that go? 5 to the 4 squared minus 6 is greater than 5 to the 4. So 4 squared is 16. Take away 6 is 10. So that's 5 to the power of 10 is greater than 5 to the power of 4. So yes, that does seem to work. So I am happy with my choices there. So those are my answers. Just checking how many I've got to do. I think that's 10 minutes. I will pause that there and I'll do the last two in a separate video.